Well, this problem looks like a nice challenge. It's got the tangent inverse and the sine inverse and square root of x. So take the derivative of all of that. The tangent inverse is the outermost function, so take the derivative of tangent inverse. Well, if it was just y equals tangent inverse of x, then the derivative would be 1 over 1 plus x squared. But we have something a little more complicated than just an x. So all of this is going to take the place of x over there. So we'd have derivative of the g function is equal to 1 over 1 plus the argument squared and then there's always the chain rule, which says now take the derivative of the inner function. So take the derivative of sine inverse. And for sine inverse, it's similar, but it's 1 over the square root of 1 minus x squared. But it's not just an x. For us, it's a square root of x. So we'd have multiply that with 1 over the square root of 1 minus the argument squared. And then we've got one last chain rule because the very innermost function is this square root of x. So then we also need times the derivative of the square root of x. So that would be derivative of a square root of x is 1 over 2 times the square root of x. And then find out where the derivative equals 0. Oh, I just noticed this should have said a letter g. So our function is called g. Find out where that derivative is set equal to 0. And good thing I've already done all the hard work. Now I can just look at it and say there is nowhere where the derivative equals 0. So in order for a fraction to equal 0, the top has to equal 0. But the top doesn't even have a variable in it.